Okay, tomorrow's test, 7 multiple choice, non-calculator, which means you need to be able to do stuff without your calculator, true? Good. Then there's going to be 1 page front and back with, let's see, how many questions are there total? 14? 7 short/long answer, where you are allowed to use your calculator. Now, does that mean that you can use your calculator on every single one? No, meaning some of those are just going to be finding the antiderivatives. Uh-oh, antiderivatives. Don't forget your plus C, or your rules, but don't forget your plus C. It happens every year on the test. Antiderivatives, people forget the plus C. So on the short, long answer, you are allowed to use your calculator, but you can't use it necessarily for every problem. It's just you can have it available. What are some other things on the short and long answers? There is going to be a motion-y problem. Hint, something to do with gravity, which I'm going to give to you. You don't have to have gravity memorized, but there is going to be a motion-y problem, something to do with gravity. You guys have done some in homework about maybe something dropping or being thrown, etc. So there is going to be something to do with motion. There's also going to be something to do with, I already said this, antiderivatives. There are going to be some antiderivatives. There is going to be an average value thing. There are going to be Riemann sums. With a table. Wait, Riemann sums, remind me. What are you doing with Riemann sums? Oh, did I just spell that backwards again? I swear, some people spell it A-I. That's alright. I mean, A-I-E. Riemann sums, what kind of Riemann sums? It could be a left, it could be a right, it could be a, you guys keep going, midpoint, or it could be a trapezoid. It could be a left or a right or a midpoint or a trapezoidal. Let's see, anything else? Right now we'll leave it at that. Those are pretty good hints. So 7 multiple choice, non-calculator, you have to know your rules, etc. 7 short, long answer hints on all of this, guys. Study the practice test, and that's why we're going to go over it today. But I did give you some hints on the short and long answer. Charlie, come on, bud. I get so distracted. Motion to do with gravity, antiderivatives, average value, Riemann sums, could be a left, right, middle, or trapezoid with a table, and you guys had some of those in your homework. I don't know why your voice just carries. Okay, coming on back. Who's Trent getting you in trouble? He's the silent one. Okay. Is that why you were laughing? Maybe not. Okay. So kiddos, you were supposed to be working on your practice test last night, but obviously, even though you have all the answers online, it doesn't mean it's super easy, right? Now I have the answers. So let's look at just a few of them, and then I'll see if you guys have any further questions. Today is for getting work done. Wait a minute. Some of you might have forgotten what I showed yesterday. Don't skip letter B. Don't skip letter B. We didn't cross that out, but we did cross out 21E today. Bridget and Aaron, we crossed out 21E. Make sure you skip that, but we added number 5, which is literally just a plug and chug to a formula. So we circled number 5, but we crossed out 21E. We didn't do 15, right, guys? No, we didn't do 15 either. If you guys do more of the practice test than what's circled, those are bonus.
Cool.
Last logistics before we just start working. Tomorrow morning there is a 0 period. You can come at 7-ish or 7:15-ish, get some coffee, get some donuts, ask a couple questions. I can't answer a couple questions for 60 kids, but I might be able to answer one or you could talk with very possibly. At 7:40, I am kicking out period 6 and BCers, and you guys are getting ready for your test starting at 7:45. Sound good? Perfect. On the front table, you guys can pile your homework spirals. Notes we're probably going to kind of pass in to me wherever I am parked around here. Make sure you have blank paper and calculator. Okay. First of all, let me go over just a few things that I think might have been tricky, especially on the first few problems. Yeah? First of all, some of you were talking to me yesterday and said, hey, number 1 stinks. Okay, yeah, maybe. But it doesn't have to. Question. Every time you have a problem, you have to think, what are you given and what are you supposed to find? In number 1, what are you given? You're given the derivative, and what else are you given? These are few that we're going to save until later. And what are you being asked to find? Wait, if you have the derivative, how do you go back to the original? You have to integrate, right? So without too much further ado, we would have to go ahead and put in f prime of x, if you want to do it this way, you can, equals 12x squared minus 6x plus 1 dx. We have to integrate both sides. If we integrate f prime, what do we get back to? Yeah, just y or f of x. You guys, hopefully you already know how to antiderive. Just skip the steps for me. What's the antiderivative of 12x squared? How's that going? Is that going all right? Okay, let's see. Wait a minute. If I need to find f of 0 and I have an unknown c, that's not going to work out so good, right? So what do I need? To the rescue. I need the clue. I need to plug it in. So, okay, the clue says, what do we know? When x is 1, f of x is 5, right? So plug in 1, that's 4. Plug in 1, that's negative 3. Plug in 1, that's 1, plus c. The clue tells us who c is. So 4 minus 3 plus 1, mental math is that going to be 2? Subtract 2 from 5, and c equals who? 3. Now we can take 3, we can plug them back in, right? Now do we have a full equation for f? And all we need to do to finish the problem, let's go back. What's our goal? Plug in 0. So f of 0 is going to end up equaling 0 minus 0 plus 3. What's my final answer? B. Is that all right? Why am I taking the time on number 1? Because first of all, a lot of you guys got stuck there. Second of all, you have a derivative, you want an original, you have to integrate, right? That's going to show up tomorrow. And you have a clue to help you find plus c. Now I'm not going to go through number 2, but question, kiddos, what are you given? The derivative. Remember, dv/dt is just another snazzy way of writing. Couldn't we just change him if you really, really want to because you don't like that notation? What's another way of writing dv/dt if you don't like him? F prime or v prime, right? So we're given a derivative. What are they asking us for? The original. And what do they give us in between? Is that really any different than number 1? They give us a derivative. We have to antiderive. We want the original, but we don't want plus c, which is why we're going to have to use our clue. We're going to plug in when t equals 4. The volume, or v, is 20. That's our clue to help us solve. You guys see the similarity between 1 and 2? Now, number 3, let's go ahead and skip ahead to number 3. I gave you a hint yesterday. But this is one that AP loves, and this is one that I kind of like. Question: if they're telling you to interpret it as an area, or tomorrow on the test, if you see something about use geometry, what are they talking about? Are you doing an antiderivative, or are you picturing the graph? Picturing the graph. Now, a lot of you look at this, and you're like, huh? Now, long story short, you can't find the antiderivative with our formulas of that function. You literally need Calc 2 strategies. Like there's no CalcAB way to solve that with an antiderivative. So we have to look at the graph. If I were you guys, I would highlight what I'm about to do because this is a very common trick question. That's what the function is, right? 9 minus x squared square rooted. A lot of us look at that and we're like, we have no clue who that guy is. Although just a few of you might be like, but I do know he has x-intercepts at both negative 3 and positive 3. And he has a y-intercept at positive 3. Huh, I wonder what special geometric shape has points at all of those. Anyway, if you squared both sides, wouldn't you have y squared equals 9 minus x squared? And then if you add x squared to the other side, this was really just a hidden circle with a radius of 3. But since it's a positive square root, we're only looking at the top part. The kiddos, you're going to maybe have to do something with area tomorrow. If the integral says from 0 to 3, how much of a circle are we looking at? Not half. Quarter of it. Which means I'm going to use area equals pi r squared, but cut into 1/4. Who's my r? Radius, 3. So 3 squared is 9, 9/4 pi is my final answer, which is C. Bridget, go ahead, kid.
How do you get the
Route?
part of it? No, I know the negative 3. So you went on the y-axis of 3?
Yeah. I plugged in, first of all, I plugged in when y is 0, and I solved. And I was like, the whole thing's going to be 0 when x is plus or minus 3. That's how I got these ones.
Yeah.
And then I plugged in, instead of setting y equal to 0, I plugged in x is 0. Does that make sense? So one way is to get 3 points and be like, I think he's a circle. The other way is to rearrange him and say, oh, he is a circle. Alright, so tomorrow there will be antiderivatives, but tomorrow there will also be things where maybe you can use geometry to solve. Are we tracking? Oh, you know what? I thought of something else. Using definite integral properties. You guys remember what I'm talking about? I'm talking about if they give you something like the integral from 0 to 4 of f of x and they don't tell you who he is equals 4, and the integral from 0 to 4 of g of x equals negative 1. Remember these from homework? You had to find like an a, b, c, and d as to the integral from 0 to 0, the integral from 0 to 4 of 2f of x minus g of x. Remember those ones? That might be a long answer. And when you're ready, you can come on back. Alright, let's go over number 4 as well, and then I'm going to open it up to you guys if you have any further questions. Because number 4, there's another common mistake you guys can sometimes make. Did anybody figure out what theorem or forever card number 4 is actually referencing? Yeah, this is MVT all the way. So if you guys are like, I didn't like number 4. Well, number 1, we did examples like MVT for integration and notes. You guys had homework problems with MVT from section 6. Sorry. 6 was last year. Section 4.4. Section 4.4. So you can go ahead and reference those. It can help me out for a bit. Without going into tons of detail, some of you have already done this work. We're going to kind of steal from you for just a second. Kiddos, how would you solve the definite integral from negative 1 to 2 of f of x dx if they give you f of x? How do we solve a definite integral? Anti-derive, and then use fundamental theorem of calculus, which tells us f of b minus f of a, so plug in 2 minus plug in negative 1. What did people get for that definite integral? Oh, someone solved it. Where are you? Number 4, the definite integral, what did you guys get after you solved this guy? 3/4.
X 2d4 plus 2x.
Oh, you're anti-deriving?
Yeah.
How about when you anti-derive and plug in b, plug in a? Does anybody want to see FTC? You plug in the top minus plug in the bottom, right? Okay, so hold on. What happened after you plugged in?
17.25.
Okay, 17.25.
That's 16.
Is that right?
Yes, 16.
Okay, but that is only the answer, guys, to the left-hand side. What do we still have chilling on the right-hand side? How do we solve for C? Hold on. Divide by, right? Algebra. You got it. Divide by. Divide by 3 or multiply by 1/3. So we have 69 over 12 is equal to C? No. F of C. Well, who's F of C? I don't get it. Wait. Who's F of X? So who's F of C? check it. Whenever you see f of c, guys, you just take the function and say, oh, find the x value. C is a number, yeah, C is the x value. So remember from MVT for when we did derivatives, right? We have to plug in the function and solve it. So if we subtract 2, that'd be subtracting 24 twelfths. 69 minus 24, 45? 45 twelfths divided by 3, 15 twelfths, right? So we get 15 twelfths after some algebra equals c cubed. What do we do with both sides? Cubed root. Oh, wait a minute, but 15 twelfths, doesn't that reduce? Isn't that 5 fourths? Cubed rooted is the same thing as 1/3 power bit, right? Cubed rooted, but we can simplify 15 twelfths to 8. So final answer is. Okay, so what are some common struggles that we might have? Number 1 and 2, if you have a derivative and they want the original, you anti-derive, and if they give you a clue, you can find plus c. Number 3, if they give you a definite integral, you can think about it as area, and if it's geometric, you can use geometric formulas to help. And number 4, MVT with integrals. When you're solving, you have to set equal to f of c, which means the function with c plugged in. So you do a lot of work over here on the antiderivative side. It takes a lot of work to get this answer, but you still have to set it equal to the function and solve. All right, my kiddos that have been working on the practice test, are there other places, other areas that you would like us, or other questions you would like us to look at? Yeah.
You guys this now first before you eat food in the derivative? Or do you use this now first?
Yeah, I actually stole from Ryan because he had already done the work, or maybe Brandon or both. Where that came from was plugging in 3x cubed plus 2 and anti-deriving to get 3/4 x to the 4th plus 2x. But remember, you had to do f of b minus f of a, so we plugged in 2. Remember, plug in 2 to everybody, minus plug in -1 to everybody. Does that make sense, Charlie? Yeah. Yeah. All right, let's go check out number 8. Now, I don't think the wording is quite as nasty as this on tomorrow's, but there is a place where you have to think about given somebody who equals an integral, how to find the instantaneous rate of change. Wait, what's instantaneous rate of change? The derivative. So just translating this little statement, we want to set f prime of x equal to average rate of change. Ew, isn't that f of b minus f of a all over b minus a? Check it. Instantaneous is the derivative, yeah? Average is the f of b minus f of a all over b minus a, yeah? Okay. Now, we're going to have to use a certain theorem to help us with this left side. How do I take the derivative of, ew, who's f? Yeah, how do I take the derivative of an integral? Take the derivative of f, I have to take the derivative of who f is, and kiddos, what theorem helps me take the derivative of an integral? FTC part 2. Am I going from a to x or a to u? A to u. How do I find the derivative of a function a to u of f of t dt? I plug in who? U, and then I multiply by u. Okay? FTC part 2, I take my derivative of an integral from a to u of f of t dt of a function of t dt. I plug in u and I say times u prime. Hold on, who is u again? Good. So plug in u times u prime, which is 2x. On the other side, ew, gross. I'm going to have 1 over pi because I have divided by pi minus 0. How do I find f of pi and f of 0?
It's square root of pi.
Oh, square root of pi. I plugged in the interval wrong, a to b. Well, f of, doesn't that mean you plug into the x spot? So I'm going to have the integral from 0 to, I got to plug in pi, right? Or root pi. Root pi squared is the same thing as pi. I'm plugging them in x squared. Root pi squared is pi. 0 to pi is sine of t dt. And then I have minus f of 0, which would be 0 to 0 squared, which is 0, of sine of t dt. What's the integral from 0 to 0 of anybody? Sweet, well that's easy. What's the integral from 0 to pi of sine of t dt? You gotta plug in, but hold on, don't we have to antiderive first? What's the antiderivative of sine of t? Negative cosine of t from 0 to pi. Remember? Times 1 over root pi. What's that end up equal? We gotta plug in pi. Cosine of pi is negative 1. Negative 1 is positive 1. Minus. Now we gotta plug in 0. Cosine of 0 is 1. Minus a negative 1. 3 plus 1. So we have 2 over root pi equals yuckiness over here. Now, they want you to solve for x. Set this guy equal to that guy. That's not a unit circle thing. Wait, are they even asking us for the x values or just how many of the x values? How many? Okay, real quick. I want you guys to go ahead and write on this one. I forget if it's written on the other side. This is definitely a calculator problem. This is not a unit circle problem. It's definitely a calculator problem. You would have to set this guy equal to y1, the sine of x squared times 2x. You have to set this guy equal to y2. And you would have to change your window settings to be your x min of 0 to your x max of root pi. And what are you looking for? When will they be equal? If you graph this guy as y1 and graph this guy as y2. Intersections. Just count how many intersections there are. That's it. In radian mode, just count how many intersections there are. Now, nice news is tomorrow multiple choice. Are any of them calculated? So maybe you won't have any ones that are quite as hard as number 8. But there was a lot of good stuff in this problem, like how do you get the derivative of an integral? Ooh, FTC part 2. How do you do average rate of change? F of b minus f of b minus a. Ooh, make sure you change the window. Change the window to 0 and root pi, otherwise life is not fun. Oh, from right here. Third corner for root pi, right? I plugged in f of b minus f of a over b minus a. This guy on top, I was solving here by plugging into my f up here. But this guy on bottom, I just kind of did 1 over it. Probably not. I think I wrote it wrong the first time I did that. Yeah. Intersection is when the 2 cross. Do you guys see 2? Do you guys see 1? I think I see 2. Right? There's one like on the left and one on the right before it ends. Yeah, I think I agree it's 2. Wait, does anybody check the answer? Let's go check it. Is that number 8? Why are we checking? Because we can. Number 8 is 2. Yeah, 1 there, 1 there. The x-axis is down here. I think I graphed it differently. But once again, remember, multiple choice tomorrow is non-calculator, which means it can't get that intense. Alright, no one else has any other huge questions. I would love to go look at one of the long answers on the back page. Yeah. 0 would be the x min. And then root pi, you can literally type in for x max to square root of pi. Yeah. Yeah. You can. Any other huge questions you guys want to look at? Let's go ahead and go peek then at the back page. Kiddos, if I were you, something that kiddos forget to study every year, I would check out the absolute value. You guys know how to do this, but you probably need to review it. How to integrate an absolute value. Yeah. So you see that there's one place it crosses over here. And then there's one place it crosses over there. So because when they're equal bridges, when they're
Oh, yeah.
So I would review that. Number 19. Has anybody tried those antiderivatives? They're good ones. How much time do we have?
Yes, I did.
Number 19. Can you just go there? How many of you guys have actually done all 4 of number 19? Hey, mommy, go do some antiderivatives. Come on, guys. Number 19. No. Remember, the answer key did, and I said, no, you guys can do it. You've learned the rule for it. I'm going to take number 19. I'm going to solve them too, but I want you guys to go ahead and take a second. How would you approach these antiderivatives? No, wouldn't you rewrite first? I mean, you can cry for like half a second, but you can't let yourself have more crying time tomorrow, right? You can cry tonight, you can cry in the morning with donuts and coffee, and then you can cry for half a second during the test. That's it. No more crying. We're tougher than that. You can have a sad face, you can have one of those sour faces. You can look at me and glare for half a second. That's it.
I'm gonna circle my tears as they fall.
I'd be like, you did this to me. I can see you with your coffee being like,
My tears came out.
Kiddos, I'm not going to solve, but how are you rewriting letter A? Come on, you're rewriting, right? Good. You can do 2ct squared plus 3t minus 1 all times t to the negative 1/2. Why is that good? Because we can distribute, right? Remember, there is no product rule for integration. There is no product rule for integration. You could rewrite it with t to the negative 1/2. Then you could bring it in and make it something that you can antiderive. We're rewriting. Dividing by t to the 1/2 is multiplying by t to the negative 1/2.
Wait,
You see what I'm doing?
so you're the one that can move square root and be the negative because of the bottom.
Good. When you multiply, you add the exponents, or you could think divide, you subtract, it's going to end up being the same thing. So you're going to end up with the integral of 2t to what power? Who's got it? 2 minus 1/2 is 3/2. Plus 3t to the 1/2 minus t to the negative 1/2. Is that something that we can antiderive? Yes, using the power rule carefully. You guys can see the rest on the answer key. Question, how would you rewrite letter B? Carefully. There's not really much to rewrite on the first part. What rule are you going to use for 3 to the x? Is it a to the x or b to the x? 1 over ln of a times a to the x plus c, right? Maybe it's b to the x, a to the x, whatever. We're going to use that rule, but we need to keep on rewriting. Yeah.
For A, when you distributed the t and I Why did we have three?
We add the powers, so 2 plus negative half. 2 is 4 over 2. 4 halves. So 4 halves minus 1 half is 3 halves.
No. Is it problem?
You mean this part, right? When we do this times this.
I thought it was this.
Oh, is it okay? How would you rewrite the next part? Good. Can't we do 4/5 times 6 to the x? Because if it's divided by 6 to the negative x, exponent rules. Isn't a negative power? Can't we bring it up and change the sign?
Yes.
Cool. How do you do the last part?
That's
1 minus cosine squared is sine squared, and when you divide by sine squared, isn't that
cosecant.
Who has an antiderivative?
Yes.
Oh, look at those T-proof skills in action. 1 minus cosine squared is sine squared, and divided by sine squared is cosecant squared, and cosecant squared has an antiderivative of negative cotangent. You guys can check the rest on the answer key, but that's how I would rewrite. Yeah. That's how I would rewrite. Letter C. Can we antiderive a power? Yeah, we got that. Can we antiderive cotangent cosecant? Or cosecant cotangent? They try to trick us. Don't let them. How do you antiderive 1 over 7n? Now hold on. Has anybody actually thought about this one? The simple power rule? What happens when you add 1? It makes 0, and over 0 power rule fails. Oh, that's right. Power rule doesn't work with negative 1. Instead, we have to go to ln. So maybe we shouldn't use power rule on the first one. Maybe we should make it 6 times 1 over n, which would be ln minus cosecant cotangent plus 1/7 times 1 over n, which is ln again. Watch out for ln, he comes at the most inopportune times. Question. What do we do for letter D? Pray that we don't make a mistake as we can't deal with squared. What do we gotta do? We gotta FOIL and then we gotta distribute, right? We gotta FOIL and then we gotta distribute. And then we can do lots of baby power rules. Once again, guys, I think all of these are reflected in the answer key. Let me make sure I actually showed work. This was number 19, right? Remember, 19's not there. There wasn't enough room. So then, where's all my nice linear work? Number 19. Oh, good thing we did B, huh? Okay, let me go finish it then. Here's letter B. All right, let's go and get the answer to letter B down. That way you guys don't have to stress about it. It's not in the answer key. That would be 4 over ln of 3 times 3 to the x minus 4 over 5 ln of 6 times 6 to the x minus 6 cotangent of x.
Yeah.
4 over ln of 3 times 3 to the x minus 4 over 5 ln of 6 times 6 to the x minus 6 cotangent of x plus c. But the rest of them, I think I have all nice and worked out. I know I forgot, I skipped B. But the rest of them, yes and yes. I got them all worked out for you, okay? Let's end with number 21. We're not going to do all of them. I'm trying to scroll and it's not on. Number 21. Remember, guys, this has all been taped, so if you want to go back and listen to something that I've done or walk through the steps with me again, etc., you can. Yep, I think I'm recording him. Oh, he's hiding. He's ready to go out. Okay, number 21. Didn't I say something about doing a Riemann sum? Oh, see, some people do spell it with IE. It's not just me. Anyway. Oh, the book spells IE? Why do I have EI in my notes? Must have been last year's book. Anyway. Didn't I write down a second ago on the practice test, or not the practice test, on the actual test, you might have using a table doing a Riemann sum? Ooh. Okay. So question, how do you use a table to do a Riemann sum? Which one do you guys like the least? Left, right, midpoint, or trapezoidal? Kiddos, go ahead and cross off letter F too. Cross off letter F. Let's just look at A, B, C, and D. Not that these are bad, but I won't, if you don't do F, I won't do it. Alright, sorry, one more time. Left, right, midpoint, or trapezoidal? Who don't you like? Trapezoidal? C or D? Okay, let's do midpoint, and then maybe we'll do trapezoidal. I think we might have time. I'm just going to set it up. For letter C, n equals 3, midpoint. For letter C, n equals 3. You guys remember how I do a little number line to help me kind of figure stuff out? Oh, wait a minute, but I have a table. Okay, hold on. In a table, how can I make 3 jumps to make rectangles? There's 1. There's 2. There's 3. Oh. There's 1, there's 2, there's 3. Okay, so for letter C, I'm doing 3 areas. Midpoint means, am I using rectangles or trapezoids? Rectangles. What are the areas of rectangles that I'm trying to plug into? Base times height. And remember, with base times height, base is like delta x, right? And height is like f of somebody. Should do f of x of who. Okay. For the first rectangle, isn't this the first rectangle's information? Okay. What's the change in base of the first rectangle from beginning to end? So I can say the first rectangle has a base of 1 times. Whose height am I going to use for midpoint? Check it. Am I going to use the left height, the y value of the left? Am I going to use the right height, the y value of the right, or am I going to use the midpoint height? See what I mean? So we can go ahead and say, okay, cool. So for the first rectangle, I have a base of 1 and a height of f of the middle, which is f of 1/2, which is going to be 1 times 4. Look at the next rectangle. What's my base of that guy? 1. Who's the middle of that guy? F of 3/2, which is the same thing as 5. So I'm using this guy in the middle, this guy in the middle, and this guy in the middle. And who's the base of my last rectangle? 1. F of, who's the middle? 5 times, which would be 1 times 3. Final midpoint approximation, 4 plus 5 plus 3 is 12. What changes when we try to do trapezoids? Oh, stink. First of all, how many trapezoids are we doing? Wait, maybe we can shorten this? Okay, I'm going to do dot, 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 a to the 6. Let's see if we can shorten this. Nice thing is, guys, remember I said this was on the long answer, which means you can use your calculator as a shortening tool, right? What's the area formula for a trapezoid? And base is like delta x, and height is like an f value, and then another f value. We'll figure those out in a second. I just have little question marks, so we'll figure them out. Let's go back to our table and say, okay, hold on. So where are the 6? Well, midpoints skip over 1, because we need the middle guy. The trapezoids say, oh, whatever. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6. What's the base of the first one? 1/2. Who are the heights on either side of the first one? Do you see them? On either side, they have 3 and 4. Can I just skip the whole f of thing above? So we're going to have 3 plus 4. Okay, the next one. Here we are. So now we're on the next one. The base, once again, is 1/2. What are my heights of that guy? On either side, don't I have 4 plus 1? We could keep on going. 1/2 times, and we're going to have 1 plus 5. 1/2 times 5 plus 2, etc., etc., etc. How will we put that in our calculator? The trapezoidal area is going to equal 1/2 is for everybody, just because these are evenly spaced, right, guys? All of them are 1/2, 1/2, 1/2. Then I'm going to have, okay, how many times is 3 used? Just once. How many times is 4 used? 2 times. So plus 2 times 4. How many times is 1 used? 2 times 1 plus 2 times 5 plus 2 times 2 plus 2 times 3 plus how many times will 4 be used? Just once. That's the way to shorten it. Now we could have kept on making our rectangles if you guys are like, I don't exactly see your whole shortcut. And it would have been the exact same thing once we put it all together. So guys, you can do the A1, A2, A3, that might help things. But some of you are going to want to shorten in your calculators to type it all in. Either way, it's not going to matter. It should end up right. So whether you do it over here, great. Or over here, great. Should you guys have a lot of your practice tests done? I hope so. But I'll be here after school until maybe 5-ish. If you guys have other questions. Otherwise, please study. Have those numbers memorized.
Sam, your phone.
I'll see you guys later.